So thanks everybody. Thanks for coming to the session, Advances in Coupled Natural and Human Systems. We are going to do our own introductions. I'll start with myself. So I am Gary Shenk, USGS at the Chesapeake Bay Program Office. I would not qualify as an early career person. I am getting ready in just a few weeks to start my 30th year in essentially this position. So the applause, but I started out with Chesapeake Research Consortium and then EPA for a very long time, moving over into USGS, but pretty much the whole time I've been working on the watershed model that we use at the Chesapeake Bay program, nitrogen and phosphorus. So fairly narrow focus for all of that. So I guess I was a bit surprised when Raleigh asked me to talk about the coupled human and natural systems, although I have been involved a little bit in some studies, but mostly I guess as a lab rat more than someone who understood the coupled human and natural systems science. So one thought did strike me as I was preparing for this to try to describe coupled human and natural systems that of course we're all in the middle of systems which include human and natural systems, but when I was first starting out my career, when I was an early career person, people were always using linear analysis methods. And this quote was something that people often said from Stan Ulam. Using a term like nonlinear science is like referring to the bulk of zoology as the study of non-elephant animals. And it always really stuck with me. I think I read this sometime in the 80s. And of course, all science is nonlinear, all nature is nonlinear, but we didn't have the conceptual models or the computing power or the numerical models to really understand how to deal with that. So it kind of strikes me that we're in the same place for couple of human and natural systems, that we are just starting to develop those conceptual models, and we have folks here that understand the mathematics and also the domain knowledge, and that's what we're going to talk about today. So with that, we're going to start our panel introductions, and I've asked each of them to give me one slide and a short introduction of themselves. So Mindy, you are first.
Okay, and I can't see it myself, but the slide is basically the trajectory of my career. So I started my work developing and applying hydrodynamic and biogeochemical models everywhere from ice flows in the Arctic to rivers in Brazil. And that culminated in the dissolved oxygen model for Puget Sound and the Salish Sea. And I helped develop that with a team of really brilliant folks at the regulatory agency in Washington State. And through that work, I was able to kind of evolve my role from actually developing the models to overseeing teams of modelers, answering some pretty sticky questions. And through that, I began interfacing with the decision makers in the agency, and I watched them really struggle with the language of science and the concept of uncertainty, which polluters often exploited as a means of maintaining status quo. Status quo doesn't benefit everyone equally. So over time, I transitioned more into this universal science translator, was able to see the political winds that really resisted change in a lot of ways. And about 8 years ago, I left my public service job into an advocacy role. So I work for a nonprofit organization in Washington State called Washington Conservation Action. We have two main functions. One of them is politics and political. And you talk about non-linear. It has been an eyeful seeing that process, but we basically endorse candidates for public office in state and local level. On the policy side, we're a policy shop as well, and I work on a lot of clean water issues related to sewage and stormwater, legacy toxic sites, and also salmon habitat. Now, salmon are absolutely critical for the cultural identity of people in Washington State and Puget Sound region, including tribal nations. And we heard a bit about tribal sovereignty yesterday. Absolutely important. In fact, cultural well-being is one of the Puget Sound vital signs as well. So tying in people and nature as well, which you'll see as part of our tagline. And through that work, I've also learned that, of course, immigrant communities in our region also fish and shellfish, not just as a means of feeding their families, but as a way of developing community-based bonds. So the policy, the work that we do is really based in environmental justice and tribal sovereignty as well. And that has led me into kind of rethinking when I I was unhappy with the pace of progress. I wanted to make change happen faster. It was actually reframing it. One of the campaigns that we run is called We Are Puget Sound. And the goal there is that everyone sees themselves in Puget Sound recovery and really telling what are science-based stories, but through a personal narrative that people can connect with because they see somebody in this book, in the campaign, that is inspirational to them. So happy to be part of this panel and bring a West Coast perspective. Thanks.
Okay. Thank you, Mindy. Next, we have Ben Geske.
Hello, my name is Ben Geske. I'm a senior engineer with the Delta Stewardship Council, which is a California state agency. I work for the science program within that agency, and a little bit of the history of my career. I started out doing more technical work, doing designing conceptual design and technical design of fish guidance systems, and that led me to work with a whole bunch of different modelers, interdisciplinary modelers, to figure out how those barriers and guidance systems would interact with the different fish species, the environment, and the humans where they were going to be in place. And so that led to me to where I'm at now, which I kind of consider myself a modeling liaison. My job is to kind of be the go-between between modelers and different state agencies and federal agencies and private firms and academia. So what I do currently is I'm leading an effort to try to build what we're calling an integrated modeling collaboratory, to where we can kind of create spaces, a better space to be able to do that interdisciplinary modeling collaborative work that everybody's been talking about on pretty much all of the panels that we've had up to date so far. So thanks again, Raleigh and Gary, for having me here. Look forward to answering some of the questions.
Thank you. So Ben and Mindy are kind of living the couple human and natural systems, and Lisa Wainger is next, and she is both living and studying these systems.
Right, I have a dual role. But first of all, I just want to say I never expected to become an economist. So that was a surprise to me, but I started out as a watershed modeler of all things, Gary.
Right.
But I was really drawn to the economics toolbox, the environmental economics toolbox, which really gives you the power to look at policies that can promote pro-environmental behaviors, but also, I think, possibly more importantly, represent the perspectives of businesses and households when we're thinking about environmental policy and making sure we're not creating undue burdens. So that's my academic work. I do socio-ecological systems modeling, but I also have another role. So there's the other role on my slide is chair of the Delta Independent Science Board. And this is oh, he says it's not the right slide, Gary.
Oh.
Thank you. Thank you, Andy. So my other role, and this is a continuation of a role I've played in the Chesapeake Bay too, where I was former chair of STAC here, and now I play a similar role out in the Delta that Ben described. And our role, so the Delta Independent Science Board promotes the use of the best science in the watershed that provides 2/3 of California's water supply. So it's a critical role. They have some very tough trade-offs to make. And and one of the things I'm doing, and the picture on the left is the complex integrated modeling, and the picture on the right, that cone of plausibility, is helping them work through the incredible variability in their system and be prepared for unexpected events. And hopefully that'll come out in some of my comments and also my talk this afternoon.
Thanks, Lisa. So I didn't start out to be a watershed modeler. My undergraduate was economics. DG Webster, and I didn't change the slide.
So I'm DG Webster. I'm at Dartmouth College in the Environmental Studies department, and I actually started out as an economist. I'm now a political economist, and since basically I was working on my dissertation back in the early 2000s, I've been working with people who do coupled human and natural systems or social ecological systems. And so I've been able to grow my own career along with these different fields that we'll be talking about today. So that's very exciting. Most of the work that I do, the main point of it is to try to understand why we are either more or less effective in terms of environmental governance, and not from a technical standpoint, but from a political and economic standpoint. So what are the forces that drive us to create good legislation and to implement it well, versus those that drive us towards creating legislation that may not be well designed or well implemented?
Thank you. So it's clear that to be part of this panel, you have to not know what you want to do in your early career. So
Wait.
Patrick.
So I
You knew all
will
along, right?
continue the theme of not knowing what you want to do, and also sort of build on what we heard on the last panel. So I am Patrick Bitterman. I'm an assistant professor at the University of Nebraska-Lincoln. At least I am for another couple weeks before I do something else. But I first started actually as an aerospace engineer. But then for family reasons, like we heard, I decided to go back to graduate school, where on day one, I was working on projects for coupled natural human systems. So I've been funded by 3 different CNH projects from NSF, including studying the resilience of agriculture in Northeast Iowa, looking at water quality and sort of rural governance structures in Southeast India. And then my work has taken me to the Lake Champlain system, where I did a postdoc with Vermont EPSCoR, working closely with the Department of Environmental Conservation there, learning a lot of great lessons from policymakers and staff with the DEC. And then once I started my position at UNL, I had the opportunity to get on a project working with Gary and DG, Raleigh, and others here as well. So I sort of live and breathe this. I don't know if I could do strictly disciplinary work. Like, everything I've done is interdisciplinary. So I don't know if I'm a good disciplinarian, but maybe that makes me a better scientist. I do consider myself a modeler, but over time, I've really sort of gotten more into thinking about the modeling process, right? So what you see up there is a dramatic reenactment of me in my lab, maybe less red string and more whiteboards and dry erase markers, thinking about how systems are connected over space, over scale, over time, and then how that really leads to good outcomes or hopefully better outcomes. So that's me.
Thanks, Patrick. So a couple of human and natural systems are kind of everything. So everything is connected, of course, as you see in this lovely illustration. But we need a better definition to start out. And so Patrick has prepared the slide, and DG is going to talk a bit about a definition of coupled human natural system.
So we all, thank you, Lisa. Lisa's good. She's got me covered here. So we all, in our disciplines, we have a tendency to look at, if we're doing anything about the environment, we either tend to look at how the environment impacts humans or how humans impact the environment. You know, oftentimes there's certainly people who don't care about humans at all, but in the end, humans are so influential that they're going to have to run into us at some point. But coupled human and natural systems specifically looks at feedbacks between both natural and human systems. So it takes those unidirectional studies and it combines them and it links them up in different ways. So you can see that in the diagrams here. The middle one is from NSF's coupled natural and human systems. They changed the acronym around on us, where you've got natural systems and you've got feedbacks within the natural systems, and then you've got human systems feedbacks within that. And then, you know, having served, for instance, on NSF panels for this award, the main thing that they look for in this is the coupling. That is, you have feedbacks from the natural system to the human and human back to natural. So understanding those things. In the social ecological systems, you see similar things. And then the Ostrom model you see there is an application of the social ecological systems paradigm by a social scientist who happened to have won a Nobel Prize a little while back. So you can see that she's emphasized the social science, but still has that natural connection. All of these have in common the idea that by capturing these feedbacks, we will understand dynamics that you don't get by looking in a unidirectional way. Usually we talk about these as complex or nonlinear dynamics, to go back to Gary's introduction. But either we have positive feedbacks or negative feedbacks that may help us to better deal with the environment. In my work in particular, I look at disconnects though. So the idea that oftentimes we aren't getting the feedbacks that we need to be able to actually deal with the problems that we're creating from the environment. So that's the definition. It's a broad one, but I'm happy to see if anybody else has anything to add.
Everybody happy with that definition? Any expansion?
Well, I'm certainly happy with it. And thank you, DG. I would just point out that while this is a framework for organizing thinking, this is not necessarily a new thing, right? My first introduction was, again, in graduate school, read a paper that came out by Jack Liu and others back in 2007. But Plato, back in like 5 BC, was talking about a lot of these issues about human impacts on the environment and those connections as well. So it's good that we have, academic frameworks and papers to guide us and those types of things. But I think a lot of these ideas come sort of naturally and intrinsically to a lot of us here in this room, right? So it's more about how do we sort of understand and break the systems down into understandable pieces so we can sort of begin to measure and understand those feedbacks such that we can have effective policy interventions, at least from my perspective.
Thanks. And I'll just point out, so there's some websites on this slide, and you see the first one there, CHANSnet. So you may hear some of the panel slip into saying CHANS rather than coupled human and natural system. That's the acronym that's used. So I'd like to hear some about why scientists would like to do this. So what is the benefit to science or scientists? Like what is the reason for doing this? Lisa, would you like to?
All right, I'll start. So I just see these models as a great crucible for evaluating which drivers we really need to include in a system to understand how it's going to behave, particularly in my work under policy change, but also climate change and any other change you want to impose on the system. So, as the challenges of climate change grow, we're really going to need to focus our efforts on the behaviors that are really having the biggest impact on the system. And I think as a modeler, doing these kind of models, because there's only so much complexity that can fit in one model. So every model needs to be parsimonious, if it can be, to create these integrated models. That doesn't always happen, but that's the ideal. And then sometimes some of my answers are going to just be more about integrating social science than CHANS writ large. So I hope you'll bear with me on that. I just think it's critical that we represent human behavior and the feedbacks to really understand how policies are going to work. And I'll just give you a very quick anecdote. So, and I'm supposed to be representing the Western states mostly to provide some variety, but I may slip into some Chesapeake Bay examples too. Okay, so in the arid West, there's a problem with over extraction of groundwater. The USDA addressed this problem by subsidizing installation of drip irrigation systems, which are much more efficient. And the policymakers were intending for this to reduce water use. But when they looked at the data, there was no change in water use. Why? Well, because people just expanded their cropland to use their full water allotment. In California, you have a fixed allotment. Or they're using cost benefit analysis to say, at what point does it make sense for me to increase my acreage? And that behavior could have been easily predicted by an economic model. And of course, a CHANS model would have helped you see the full impacts to the system, spatial and temporal variability. So we really need these integrated models to be test beds for policy, particularly when there are these potential unexpected behaviors.
So I'll reiterate that a big benefit to science is understanding the complex interactions and the feedbacks that occur when we look at things more holistically than just in our individual disciplines. And so oftentimes, if you read this literature, what you come across is things like cascade effects and when are they triggered and how do they move through a system, both the natural side of it and the social side of it, as well as threshold effects. So the Goulburn catchment in Australia is this example. HABs are also very commonly used as an example of threshold effects, where we know that there's a threshold effect in the natural system, but again, that creates a temporal disconnect so that people who are putting all the nutrients into the system don't necessarily realize that they're causing harm until that threshold is already crossed, right? So there are some things that are great for policy and that has a great policy implications, but also has really important implications just as basic science. I'll give you one more example before I hand over is with our climate change models, for instance. Most of our climate change models don't include human reactions and responses. And that is one of the main reasons they tend to underpredict how much climate change we're experiencing.
Thank you. So Mindy, kind of expanding that into policy, as I mentioned, this is all connected. Your answers on science were also about policy as well. So Mindy, do you want to talk about kind of the advantages of using the CHANS approach that you've seen?
Yeah, you bet. And CHANS is a completely new acronym to me, so I didn't know I was using them, but apparently I was. I guess it's the benefits, but also the risks of not doing this. Too often, the framing has been on nailing down every last element of the natural system and then figuring out how it works. Very rarely do those end with, it works great, we're fine, right? There's always something that we want people to do differently, or communities to do differently, or sectors to do differently. And so we take these wonderfully developed models out to those communities. They say, well, what's in it for me? What's my bottom line? And what we haven't factored in is the human decision-making process. Again, highly nonlinear, which is where social science comes in. And I think in our region, at least, it took a long time for the hard scientists to even let the soft scientists into the room as the non-quantifiables, but they are quantifiable. They really are. And it turns out we're doing better because of it. And we have to think through what is the behavior change we want to look at. And until we look at it from a human-centric or a people-centric perspective, we're not going to get the behavior change, because just knowing what the right answer is not enough to compel behavior change. So if you think about it from your own personal health, you know you need to exercise every day, you need to eat well, you need to tell your family you love them. How many of you have done every single one of those every day? You don't. You know what the right answer is. You're very smart people, and yet you're very complicated individuals too. So until we kind of reflect the complexity of decision making, not just within the public realm, but also within the political realm, we can't get the change that we're finding in the natural resource models.
Ben, did you want to crack at this question on the benefits of policy?
Yeah, I think that we've covered quite a bit of the benefits, and I think that, you know, I would definitely advocate for using this approach. You know, I've got some specific examples that I could talk about later about where we can kind of see some failures by not taking this approach, and some of those projects having to kind of work backwards in their design process before implementation, and kind of realizing halfway through the project that taking this type of approach was beneficial, and in fact the only way to be able to implement a project. And so there's many of that. But I did also want to say that taking this approach and doing it the right way, we do give up a couple of things. I think we give up time sometimes. I think it takes a lot longer to do these things right. It takes longer to find the right people to talk to from all these different disciplines in hard sciences and soft sciences, and it's hard to find time in all of their schedules in a venue that works for everybody to have these these complex conversations. And bringing more people to the table also sometimes makes it harder to find consensus on decisions that we're making when we're trying to kind of design alternative solutions. So sometimes, most of the time, you don't get everybody in agreement. But in the end, I think taking this approach gives you a much higher level of success in implementing a project that benefits the most amount of people.
Thanks. That was a great segue into, I was going to ask if there are any sort of downsides of this, and you've highlighted that it's more difficult. And
yeah, and can I just add one more
Yeah,
thing
please.
too, because a lot of my job is to is to kind of be that liaison and bring these folks together. A lot of times the people that you're trying to include are very passionate about their job, but they don't have the time or the resources or the money. I mean, if we're talking about like reaching out outside of state and federal services where people can kind of volunteer some of their time to be a part of this, a lot of the people that that need to be involved in this are community members or, you know, people that work for private firms. And so it's hard to get the money and create some it's hard to create some to provide incentives for those folks to be able to be there when I'm not the one that's in control of the money.
Yeah. So that's great. So Chans is great to do because it is the way the world works, but it's difficult because it's complex. Are there more? Is there more? Does anyone want to add to that sort of the difficulties that, or is that? Or should we leave that there?
Can I just go back just a little bit? I mean, not so much the difficulties, but I kind of want to talk about the sort of the interface between the benefits to scientists and also to policymakers. So first of all, I want to say we often talk a lot about, you know, doing coupled models, right? And a lot of us are sort of employed doing that, but you can do Chan's work without doing computational modeling, right? You can have this sort of understanding without writing any bit of code. That said, I'm going to tell you a story about writing code. So I think one of the things that sort of is a real benefit is it's, at least to me, and I do a lot of agent-based modeling, and our models make predictions, right? And those are good, but I think the real benefit to scientists and science in general is taking this approach, using it in the context of different types of models. It allows you to learn more about the system itself, right? So where do we need to go put more instruments? Where do we need more data? Who else do we need to talk to have a more whole or a holistic view of the system that we are studying, right? So the models are good. The predictions are most of the time good, not always, but I think getting that understanding, I think, is really, really useful. My anecdote real quickly, since I have the microphone, is an example from our work in the Lake Champlain Basin in Vermont, where they know that there is a HAB problem in the shallow bays of Lake Champlain, especially Missisquoi Bay, and the state has an acknowledgement that they need to do a lot of work to clean it up, right? And they put a lot of money behind this. They have a TMDL just like here. It's smaller, but they do have a TMDL mostly for phosphorus. And through the use of coupled models and the engagement with policymakers, what we found is the importance that there is non-stationarity in the system. That, in fact, all of the money, all of the effort being put into cleaning up the watershed is only going to roughly offset climate change, right? So it tells us something about the decisions we've made. It tells us something about how we've spent money, but it also shows that we have to be able to adapt, and our models and our frameworks, you know, tell us that, such that we can, again, lead towards better outcomes, because the world is changing and we need this type of framework to help us figure out how we can change with it.
And I appreciate that clarification, because it was occurring to me that every person in this room means something different when you say the word model. Mm-hmm. And so it can mean many different things and can be applied. So thank you for that. And Lisa wanted to follow up.
Yeah, I think you raised some really good points, Patrick. I wanted to also mention just the power of collaborative modeling. So that's not Chan specific, but I've seen the power of even sitting down with stakeholders, really meaningfully engage with them and testing their hypotheses about how the system works. And in the Oyster Futures project that maybe some of you have heard about, I think we saw really good success in just listening to the watermen who had a different vision of how the system worked, testing that with data and models. And then we came to a common understanding of how the system worked. And it surprised me how well it worked. So
I'm going to chime in too. Coming from not the hard sciences, but the harder sciences. Because, you know, people lie a lot, even to themselves. So it is harder. And one thing, thinking about the work or the roundtable just before this, it can be problematic, especially for people who are just getting started out, to be able to demonstrate that they have the kind of metrics that you might get if you were just staying in your discipline and everybody's citing everybody. And so you have really good citation figures and things like that. And being able to position yourself for promotion and tenure can be quite difficult depending on where you're at. I am in an environmental studies department. I made that choice specifically because I knew that a gov department or an econ department, a discipline specific department wouldn't really appreciate what I do so much. But on the plus side, it advances our knowledge, but it also advances our methods. It forces us to think harder about the connections within the system. We have, over the last centuries, in science, natural or physical science, we have moved from everybody was a philosopher. Right? Back in the day, everybody was a philosopher. And then we had the natural philosophers and the more ethical side of things. And then we branched out into these disciplines. And there was good reason to do that because we needed to break down the world, right? To break it into smaller, more understandable chunks. But now we have the computing power, we have the knowledge, and we have the human resources, right? Back then, for actually not all that far long ago, right? Most people didn't get the kind of education that you need to do these kinds of things. And so now we have the human resources, we have the computing resources to really bring all of those things together. That said, if you're sitting there being like, dude, this is crazy. I don't know what these people are talking about. I'm happy in my that's good too, right? It's not an either or kind of thing, right? We need the people doing the deep, specific disciplinary research, and we need the people who are building those bridges. But yeah, it is hard in a lot of ways.
So I wanted to ask about when you're in a project, it kind of builds a little bit off of that. You know, how number of you have mentioned how difficult this is, and so clearly you can't do this yourself. You have to work effectively. I mean, not you personally.
That's absolutely true. I have been there so many times.
So how do you work effectively in teams? Is there any sort of learned advice from the battlefield of working across disciplines?
Yeah, I found that there isn't an answer to that. I think that there's many different ways to approach kind of this teamwork. And I asked the question to the younger generation, you know, during the last panel, what is kind of like your preferred venue for working in these environments? Because I'm still trying to figure that out. You know, we do a combination of, you know, virtual knowledge sharing and Q&A sessions. We do kind of more ongoing professionally facilitated work groups. We do you know, work in online forums, and we've got nonprofit organizations that, you know, that put on annual conferences. We do all types of stuff. So I think it's, you know, it's continuing to expand on that and listening to the feedback that you get from kind of each one of those venues, asking the folks, how did that work for you? And, you know, and really listening to what worked and what didn't work. So, you know, when I mentioned that I'm kind of trying to right now create this integrated modeling collaboratory, that's the challenge right now, right? Is to figure out how to get all of these different folks that work differently, you know, into all of these different venues that are going to work, you know, moving forward. So I think it's just, I'll just sum it up by saying I don't think there is an answer. I think it's just to keep your mind open to anything that works, and listen to the people that are showing up.
Thank you. And Mindy, I guess sticking with the kind of practical side of this, did you have an answer to that question?
One thing I wanted to add, I think the question was more aimed at how do you develop these models, but I'm also thinking from an end user perspective, how it's going to be used, who are the decision makers in that. And something we heard from the early career panel is that social justice is just interwoven to everything that we do. And we all realize that those that cause harm are different from the people who feel that harm. And there's disproportionate impacts all over the place. Right now, I'm seeing a lot of my partner organizations, BIPOC-led nonprofit organizations, some of the tribes that I work with, they're absolutely being inundated by requests to engage, which is both good and bad. Great that we want to do that. And we heard a little bit yesterday about some of the pressures that the Chesapeake tribes are feeling here. And as newly federally recognized tribes, there's a lot that needs to happen for them to get their systems working. But I would still urge us, and think back to yesterday's conversations, making sure that the people that are represented in your tools, whether they're part of the development of or the end users of, they need to reflect the broader community. And the traditional outreach methods advantage people like me, a white woman, middle class, whose day job it is to work on water quality and habitat in Puget Sound. That doesn't work for everyone. And if we really want to make sure that our models are truly representative, or our processes are representative, we're really going to have to think about different ways of reaching out. And something that we've been working on in our region is there are community-based organizations that may not identify as, say, environmental organizations. Maybe they're health-based, or they're helping people with I don't know, toxics in the home or something like that. It's those types of organizations that are more your trusted messengers, frankly, and developing relationships through those organizations might be a good and effective way to start on that. So just thinking back to the human side of these systems is making a very intentional decision on how to do that, and then make sure that it's gathered in a way that is ethical, but also then adds value to the community. We heard yesterday from Ashley Spivey about reciprocity, which is incredibly important to make sure that this is not simply, you're not mining people information for information. It's not extractive, but is more additive and valuable for them as well.
Did you have a sort of a concrete example?
There in Washington state, we passed what's called the HEAL Act, a state law that is an environmental justice law. And in that, it does require consultation with people who are impacted by different projects. And right now, we set up an environmental justice council, an environmental justice task force, and they're trying to figure out what are some reasonable policies and procedures to use for that particular engagement. But again, unless folks are truly consulted and involved in this, then your results will not be meaningful to them. And if you are like me in the business of changing people's behavior, you're going to need to rethink that. So if you're interested in more of some of these elements coming out of Washington State, I'm happy to talk afterwards about that.
Thank you. And I see Ben.
Yeah, I just wanted to add one thing. One thing that stuck from yesterday, as I believe her name was Hillary, she was talking about saving the Bay for the people, not from the people. And that stuck with me today. And I was thinking about that just now as you were talking about that. And I totally agree with what you're saying. And I think the timing of that taking that approach is very important. And the timing is that I found that the earlier you can do that in bringing folks in making them feel a part of the team and getting their perspective in the very beginning while you're creating this conceptual, not computational, conceptual integrated model from the very, very beginning, you get buy-in. So you build partners instead of enemies. And if you don't bring them, there's kind of the trade-offs right there, right? You're along with kind of getting that buy-in, you're getting all kinds of knowledge, and you're getting, all kinds of, pointed towards other tools that you may not even know have existed. So I think there's just so much benefit in seeking that very, very early in these types of processes.
I think, yeah, DG.
So it's great to hear from people who are in the trenches, as it were. But I do want to say that if it has to be done right, because there is a lot of what we call stakeholder fatigue. And there's a lot of evidence that if you try to engage with stakeholders or with tribal nations, even if you do try, but you're doing it in a unidirectional communication kind of way. So you're just providing them with information. They may provide you with information, but you're not actually intending to do anything about it. That is just going to alienate everybody. Right? So you guys listen to people, right? And that's what makes you so successful in what you do and engaging with stakeholders and the public. But if you have somebody who's just doing it in a performative manner to make it seem like you're being inclusive, then that is going to backfire entirely. And so it's very important when you're doing these kinds of things to actually have that respect for the other people. And if I can switch a little bit to what it's like in terms of scientific collaboration, I often have sort of the opposite problem where I have to establish my credentials to earn the respect of my natural science colleagues because of this whole soft sciences versus hard sciences divide. Oftentimes my natural science colleagues think I'm just there to help them communicate their ideas and convince other people that they're right. I mean, I don't know how many times that has happened to me. And no, I'm there to answer real scientific questions that are really important on the social science and the Chan side of things. The other thing that can be very important if you're engaging in the collaborative science end of things is just developing shared vocabulary. As you saw with our intro diagram, right? There's all of these different versions of what we're calling Chans now, but everybody has their own languages. And oftentimes we use the same words in very different ways, or sometimes similar ways, but just different enough that it can completely prevent us from actually communicating. That's another thing. I don't know how many times I've been in a meeting where people are just going in circles, and you're just like, you're talking about different things, but using the same words, people. So being able to be aware of that and think hard, not just about what the information you're trying to project to other people, but how they view that information, how they're processing that information, and then also receiving the information that comes back to them. That is key regardless in any of these kinds of things. And it takes time to develop that skill and to be able to really do it well.
Yeah, thank you. Lisa or Patrick, any kind of war stories of trying to get folks together either in reality or in academia?
I don't want to belabor this. I just would like to, when we economists get together in our little cabals, this is what we complain about. I'd like to share this with you. We tend to be at the end of the stream of coupled models. So we're waiting for your climate change models, and then your watershed models, and then your biotic models, and all those things have to be linked up. And then we get to the stuff we can model. And in terms of sort of managing an NSF project, modelers want to take every single day to just work on their biophysical models. And that leaves us economists with zero time to analyze your data in our models. So you really need a good project manager who can encourage people to provide results earlier in the process, not on the last day of the project. And that's my sentence.
I think you're referring to a specific project that we had together 5 or 6 years ago. Yeah.
I'm referring to 5 specific projects.
I just agree with everybody here, but just to say one other thing, like as somebody that's both written grants and then reviewed them, sat on panels, right? At least for NSF, you have to have a broader impact section, right? And quite often, this is a quick anecdote, you'll read them, it'll be like education and outreach. Like somehow that's going to solve it, right? Like we are going to take what we learn and we're just going to push it out into the world and we're going to assume that there will be broader impacts, right? And that's not nearly enough. And when I've sat on these panels, in fact, some of the best examples of well-written broader impacts actually comes when I sit on panels that review the dissertation improvement grants. So a lot of the young folks, again, speaking to the earlier panel, are thinking a lot more about these issues. How do we do outreach, right? How do we bring people in early? How do we do that more convergent work as opposed to, again, we're just gonna write some papers and assume other people read it. So I will say we do need to do better work there as academics as well.
Yeah, I just wanted to just add one thing, and I know we had in there kind of like methods and how we do this, right? And there's a lot of people that want to do this type of work. And so one of the things that we do when we have research money that we give out to teams of folks that are doing this type of doing scientific research and integrated modeling is now what we're trying to do. We realize that this needs to be a change in the culture, like the scientific, the way that we kind of do things. And we recognize that most of the people also recognize this, but as I mentioned before, it does take more time. It does take more work. It does take more money to do this the right way. So one of the things that we can do as people that provide, money for these types of contracts is to make sure that we're putting specific like CNH type tasks and deliverables in the contracts and providing money for those types of tasks and deliverables. And the more that we do that, the more commonplace that becomes and the better we get at it. And it allows people to kind of, don't feel like it's something extra that they have to like volunteer their time to do. It just becomes part of like how we do business moving forward. So that's one method, is adding that money and that language in contracts kind of moving forward.
Thanks. That was great. And so we were also wondering about sort of on the side of getting funded and looking for funding. I'm sure most of the people here are in the getting funded rather than funding. And so are there particular tricks to sort of getting funded, and are there also barriers? Are there institutional barriers? Is it hard to put the teams together for funding? Or are there things that work great?
So I'll just talk about sort of NSF end of things. We've mentioned the CNH program several times. Unfortunately, that became DICES. And then now actually DICES is disappearing. So that was one of the main sources of funding, because if you're going to have a bunch of people on a project, it's going to cost a lot of money, right? You're talking about hundreds of thousands of dollars a year, especially across multiple institutions. And then you've got everybody's indirects piling up on everybody else's indirects. So now, though, NSF is starting the Confronting Hazards, Impacts, and Risks for a Resilient Planet program, the CHIRP program, which is one that is a good program to go for if you're looking at coupled human and natural systems kinds of things. Also, they have the GCR, the General Convergence Research Program, which is a good one. And then you can always approach your program officers as well in your own discipline and ask them, are you interested in this? Do you have ideas about how this could move forward with other things? There's also EAGER awards, IGERT awards, if you're more on the teaching side of things. But generally speaking, you've got to network a lot more, I think, so that you can know the right people. This is actually I didn't mention this before. This is my first lesson to any student on a group project, is pick the right people to work with. Pick the people, make sure you know who they are and they're going to do their work, because as Lisa said, oftentimes if the first part doesn't get done, the rest of it collapses. But knowing the people, so networking is key. There's also a number of professional associations that you can go to if you're interested in networking like this. So there's the Resilience Alliance, which was started by C.S. Halling and Eleanor Ostrom. If you know those names from biology, you might know Buzz Halling. There's the Association for the Environmental Studies, Environmental Studies and Sciences. And I'm forgetting Ostrom's other one, which is the IASC, International Association for the Study of the Commons. They support quite a lot. And the Resilience Alliance. Those are all good places to meet people who do these kinds of things.
So switching gears a little bit, at any scientific meeting, we always talk about uncertainty. And as we have, anytime you're adding additional components to a model or modeling system, kind of multiplying uncertainty in some ways. And so are there any sort of advice for working with that or communicating that? And I think Mindy, you mentioned it a little bit, but I don't know if you or anyone else wants to expand.
Uncertainty obviously is not good when you're trying to showcase your the analysis that you have as trying to advocate for it being a big part of somebody's decision making if you don't have a high level of certainty. But I'm going to try to be kind of a glasses half full kind of guy on this and say why like uncertainty can be good if you really dig into why there's uncertainty. I think that it can daylight gaps in like your monitoring and in your data collecting systems. I think if you really figure out why there's uncertainty or where there's uncertainty, then you can, that can lead you to enhancing the systems that collect the information that get plugged into the models that then provide those results that might have uncertainty. So kind of maybe using that in a positive way.
So we've just kind of been
Mindy.
going, oh, sorry. Go ahead.
That's okay. Well, in my introduction, I talked about uncertainty, and we've started to talk about the language of science, which is just fundamentally different than the language of maybe the public or political organizations as well. And something I did want to talk about is that to be an honest science, you have to talk about uncertainty. That's just a standard part of what we do. You have to do that. The problem is when you're talking to an elected official, and if you lead with uncertainty, the conclusion is you have no idea what you're talking about. And so this is where sometimes, and I have seen, nationally renowned scientists pilloried by the scientific community because they're not talking about uncertainty, but they can't. If they're talking to Congress about that, they have to be far more definitive about it. So it is a catch-22 on that. I have no idea what the solution is, except that the scientific communication within a group like this is fundamentally different than if I were talking to a group of elected officials. It just is. But just know that you have to code switch. You have to intentionally code switch in that. And it's not that you're not being honest. It's just not what is going to be helpful for the elected officials in that particular case. Again, it's not because they're dummies at all, but what they're hearing is what are the risks. And as soon as you talk about uncertainty, all they see is you don't know what you're talking about. And as I mentioned, I absolutely saw this exploited by polluters who really love status quo. And in fact, if anybody saw the recent PFAS lawsuit against EPA by the chemical industry, you'll see that it's going to question science and the uncertainty of science. It's just how to spook progress, unfortunately. It's just the reality of how to stop progress. So just know that issue is out there. I don't know what the solution is myself, but I definitely found myself in situations where when I was talking with my scientific colleagues, I had to speak about things fundamentally different than when I was talking to the people who were going to be acting on the model results that we had.
And maybe one way to approach that, you say you don't have the answer. I don't have necessarily the answer either, but we've talked a little bit about best available science and best available information. There's always going to be some level of uncertainty, but if we can just point to the fact that we're using the best, and we can prove that we're using the best available information, the best available science, then relative to the other information, the information that I'm providing, even though it has some uncertainty, is more certain than any other approach. So,
thank you. Did you want to add something before we? Yep.
So just on this, again, on the science side of things, not to contradict anything these guys have said, there is a literature on how you deal with uncertainty in CHANS and SES, particularly because of the complex nature of the feedbacks that we're trying to capture in these systems. So there are best practices, I guess we can call them, in terms of when you're doing modeling, how you document your models. So there's actually a practice of how you document your models to make it clear and transparent how your model is constructed and what everything means, even if it's a very complex, complicated model. Also how you test your model, how you ground truth it. If you can, obviously using good, strong quantitative data, but then if you can't, how you can use, for instance, expert knowledge and other things to try to ground truth your models. And then the third approach to uncertainty, which is very key in these fields, is using going maybe beyond just your typical sensitivity analysis to do what often is referred to as robustness analysis, where you're really projecting lots of possible, if you're going to do predictions, especially you're projecting lots of possible futures instead of one or a few, and you're really looking to see, well, how many of these futures are really stable given the inputs that we're putting into our model. So there's various ways to address uncertainty in these kinds of situations that have been developed over the last few decades.
Thank you. So we have about 5 minutes before we open it up for questions. And we've been kind of jumping around, but we're going to go straight down and give everybody 1 minute to kind of give a top line lessons learned or vision for the future of where you think CHANS is going. And so let's start here with DG for 60 seconds.
This is why Lisa didn't want to sit in this chair, isn't it?
Exactly.
So I think sort of the big takeaway is this is really important, right? To be able to do this kind of work is critical in what is increasingly being called a polycrisis. We have climate change, but we have all of these other environmental problems, plastics pollutions, all of these things that are building up because the population is growing and we are developing and we are buying and selling so many things, right? So it's fundamentally important to understand these couple human and natural systems, but it is difficult and it requires long-term strategy. It requires people who are willing to spend their time outside of their comfort zones, reading literatures that they're not necessarily comfortable with. I have learned so much more, for instance, about fisheries biology in my work than I ever wanted to, but I had to, right? Because I wanted to link up to that science. So it's difficult, but it's worth it, I think is going to be my big takeaway.
Great. So yeah, I don't think I need 2 mics. That would be too much. I'm going to focus on embracing uncertainty. So this kind of harkens back a little bit to the last question. We have a system we have non-stationarity problems, right? The history is becoming a less good predictor of the future. And one way to deal with that is to really embrace adaptive management and try to think about ways our policies will break under unexpected futures. And I think SES model or socioecological systems models, or CHANs, are a critical part of this. And I'll just give a quick anecdote to cement the idea. So we're just finishing up a project that looks at how is aquaculture going to be challenged by climate change in the Bay. And we were expecting to find acidification effects, but really we found other effects that we weren't expecting. So the model did give us insights that we hadn't thought would occur in terms of what's going to hurt or help profitability in the future. But I think one of the key take homes that we got out of this is an example of how you can look forward to how to adapt is just 2 policies could go a long way toward improving aquaculture profitability. One is providing lease flexibility because sites really matter where you're producing your oysters. And then investments in technological improvements in survival had basically multiplier effects. And these were things that I don't think we would have known without the integrated model. So I think we need to really be thinking about this adaptive strategies.
Great. Well, I think final opportunities that I see is we heard from the early career panel this morning about reframing the problems and the issues as people first. I really think that that's important. And listening in on what's been happening in the Chesapeake Bay over the past several decades, there's clearly a nitrogen problem from agricultural sources. We have our own challenges with agriculture in Washington state as well. But rather than continuing to estimate, well, what are the nitrogen loads from different practices or how they might be reduced as a result of BMPs? What if you started from decision-making within the farming community and built those science, build your science around that, but frame it as people first. And I really do think that tackling some of those issues, you're going to identify what drives farmers. And in behavior change, too often there's the bell curve of life where you have your early adopters, your innovators who are just going to figure out new things that need to be done and they're going to do them. And you have your laggards at the end of the spectrum that basically, no way, hell no, ain't going to do it, make me. And then you've got the people in the middle, the show me and the help me people. I think if we focus more on show me and how do they need to be shown, and help me, what exactly do they need from technical assistance and financial assistance, test some things and figure out what works and design your model from that change first, and then build the science, the natural resources science around that. I think that would really, really move us forward in so many different ways.
Well, Lisa stole most of mine, but to build on that, though, I would say important lessons in addition to non-stationarity. Obviously, lags are a big problem, right? We need to deal with. But one of the other lessons I've learned is the importance of science-based and science-literate leadership. Frankly, we like to think that there's a lot of grassroots, right? We all sort of agree on some of the fundamentals here. We need to do a lot more work. But a lot of the decision making, a lot of the power actually comes from the top, right? And I've seen this be effective and ineffective in different settings. Again, to go back to my work in Vermont, the head of the Department of Environmental Conservation is a former environmental engineer, and she's amazing, right? And things actually get done. Where I'm from in Iowa, the head of the DNR is a former ag lobbyist. it goes the other direction, right? So there are constraints on what can get done. And I think that's important to acknowledge and recognize as well. In terms of a vision, obviously more social science. I'm a social scientist, but I do think we also need to bring in people from arts and humanities a lot more too. So I mean, frankly, I think it's not that the science is easy, but I think when we're trying to change minds, when we're trying to convince people, we have to be better storytellers. And whether that's through narratives or art pieces or, connecting and telling those types of stories about people that are on the front lines of climate change, on, disappearing islands and things like that. I think that's really, really important to do. I saw a great presentation a couple months ago from somebody in a French department that told stories about the South Pacific and how people are really on the front lines. And it moved me in a way that, seeing a graph of sea level rise isn't going to, right? And I think that's super, super important.
Yeah, thanks, Patrick. I think that you stole a little bit of my answer as well, but I like, excuse me, it was a good segue. The way that I envisioned us making the most progress in taking this type of approach was, I was going to say that we really need champions from the executive and agency director level. We really need that. And I think that it's not just money to pour into it. It's also, a lot of us work for state and federal agencies, and we want the ability to engage in more of these types of activities, but it's not written into our duty statement. So there's ways that without just money that we can make changes, from the top. If we are able to tell that story about why and kind of justify that there's going to be a return on that investment. I really do like the idea of the bringing in the arts and humanities. I've been thinking about, in this day and age, most people get their information from like YouTube and Instagram and stuff. It's a very effective way to come across. And we've got a public relations department in our agency that does a really good job of doing that. I think if we can tell our complex story and include creative ways to show the return on the investment of these types of approaches to these top level folks in the agencies, then I see that that's where we're going to make the most progress in the near future.
Hey, thank you all. We're going to open it up for questions from the room. Andy.
Thanks, everybody. So I'm going to bring this back to where we are in Chesapeake Bay restoration effort. We heard a talk by Hillary Falk yesterday in which she referred to the season report issued by STAC as got translated as kale salad, right? It's hard messages that come through about what we think may need to be done. Obviously, it's not all certain. So there's two themes that I keep thinking about, and this goes back to a workshop we had a few weeks ago as well. One is the issue of how we talk about uncertainty. The other is, which I think is key, is how do you convince people, and this could be individuals, it could be interest groups, it can be institutions, including agencies, how do you convince them to do something that makes them uncomfortable? Which I think you've all referred to in one way or another, because they are going to have to make uncomfortable choices. With regard to the uncertainty issue, I think the way it's been used as a cudgel is clearly pretty hypocritical, because in every phase of life, every decision everybody makes, whether it's personal or business, investments in the stock market, their health, you name it, they are accepting a level of uncertainty. They just aren't necessarily quantified. It can be quantified, it often gets ignored. So one of the things we talked about last month was, let's turn that around and talk about a decision not to do something is a decision, and you are accepting a level of risk that you're not willing to quantify. So I think you sort of have to turn it around and say, if you're not willing to make a decision, under uncertainty, then what uncertainty are you actually building in? What actual risk? What's it going to cost you? So I'm just curious what your reactions are.
So if you saw my talk yesterday, I've been doing a lot of research on news media coverage of the Chesapeake Bay. And the thing that got the most coverage was called Pfiesteria hysteria. If you've been around for a while, you remember that from 1997. And so as a social scientist, my answer would be, it's not about the uncertainty. It's about the incentives, because we do act under uncertainty all the time. And that includes, there's actually a decision makers like there's a science of understanding decision makers, and action bias is one of the things that if it's uncertain, we still want to make some kind of action so people think we're doing something. The question is, what are your incentives and how do you align those incentives? Sometimes that's through communication. In Chesapeake Bay program, a lot of that is through matching grants and funding. That's part of why Chesapeake Bay program has been as effective as it has been. So I do think science communication is important, and addressing uncertainty is important. But if you're looking at somebody else and expecting them to have the same value system that you do, you're not going to be able to communicate with them very well, because they're going to see that and they're going to be like, well, they don't value what I value. Why should I listen? So thinking about things, not just again unidirectionally, but also hearing back is important.
So my comments would build directly on that. So as an economist, we think mostly about incentives. And we don't have a lot of faith that voluntary actions get you where you want to go. And I think, the TMDL is an example. We had voluntary agreements. We didn't see enough progress. We saw some progress, right? People are willing to do some things voluntarily, but not enough. And so then we went to the legal framework of, we have these caps, they are enforceable. And then we still didn't achieve the goals. So, there are some issues, and they're well described in CSER, that are big problems with achieving the TMDLs. And so we just keep pushing this stuff under the rug because there really is no policy lever that does what we want it to do. So, as an economist, the quickest way to change behavior is through price signals. And so I would suggest we need, and regulations play a part in that, right? You have to set a cap, and then maybe you allow trading under the cap to create efficiencies. Maybe folks don't understand that's what trading is really about. It's about achieving a pollution cap for the least cost way. That's really the point of trading. So it makes it easier to set a more restrictive cap if you let people trade, for example. We've had a lot of pushback to trading. And we just need to get serious about accepting the risk that maybe every little square inch of water in the bay isn't going to be as pristine as we'd like, but overall we can achieve good things if we allow some of this targeting, essentially.
I'd like to add a little bit to that as well. I think that you said that you were asking people to make decisions that they're not going to be comfortable with, because of a certain level of uncertainty. And I think one thing that we can do to kind of soften that a little bit is when we provide alternative solutions to people, or choices and decisions they can make, with these plans that we include an adaptive management plan that comes along with it, which includes monitoring, after the decision is made and the project is moving forward, that we have a way to gauge and answer some of that initial uncertainty, right? And if we listen to them about what is the uncertainty that they are concerned about, then we can design an adaptive management and monitoring system, moving forward in that project that will hopefully be able to answer, lessen that uncertainty. So I think maybe just including, a plug for, the adaptive management side of projects is maybe softens that a little bit and gives them, relaxes their shoulders a little bit when they're going to make that decision.
I'm wondering whether throughout your careers you've noticed that there was some common denominator where some of these feedback loops were more successful with human intervention into the natural systems. And what do you guys think that common denominator is? And if there is like a couple intervention points that we can kind of tackle that do help it become successful, how do you intend to do that in the future?
Okay, I'll start. So most of my work focuses on power disconnects. We tend to see that these systems are effectively managed when the people who bear the brunt of the costs of pollution or natural resource degradation are the ones who actually make the decisions, because it's important to them. There are cases where maybe they don't have sufficient knowledge or something like that, but usually that is relatively easy to overcome when the incentives are there. But when you have vested interests who are able to insulate themselves from the costs of their activities, then you tend to have these long-term, large-scale environmental issues. And so sometimes you have to think beyond just this environmental issue, right? Beyond just the water quality in the Chesapeake Bay, to think about, well, what's wrong with the entire system? And one of the things you see, for instance, in the 1970s, when we had the environmental movement, we tend to look at that in isolation, but it wasn't just an environmental movement, right? You had the civil rights movement, you had the Chicano rights movement, you had the Asian rights movement, you had the anti-war movement, the Native Americans fighting for their own rights. And all of those groups cared about the environment in some way. Right. There were synergies there, and there was pressure there that really caused large-scale changes. And so another sort of part of coupled human and natural systems in that holistic approach is thinking about, maybe it's not harder if we think about all of this together from a political perspective. Maybe if we can bring these together and link up the things we care about to the things that other people already care about, then that may create that change to actually narrow some of those disconnects and make it so those vested interests have less power.
Let's go here.
I heard talk from a colleague at it's about climate change in Hopkins recently, where he talked about industrial policy. I've noticed that there hasn't been a lot of discussion here about industrial policy. So tell the students that unless you're dealing with trade-offs, you're not doing actual policy, right? And that industrial policy is absolutely key to solving the climate change problem. But what do you think about that? Tom's like, is that one of the places where we're lagging?
I mean, so the poultry industry, right, is the chicken in the room, but also agriculture more broadly, right? This is the general thing that you're talking about, and it's interesting. There have been various industry attempts to deal with like the manure problem and things like that. Certainly, when we talk about win-win solutions, that can often be a real path forward. So not just in the Chesapeake Bay, but in other examples we have where businesses and industries see that they could have a competitive advantage by essentially pushing for. So oftentimes, yeah, exactly. There you go. The Montreal Protocol, DuPont, right? DuPont was all about reducing CFCs because they had developed the technology to replace them. And they wanted their competitors to be like, to be at a disadvantage. Of course, they only had 4 competitors. So I would circle though back to the whole non-point source pollution issue as well. And you can't really, I mean, you can do the CAFO, you can do the poultry, as an industry, but tackling all of those small farms is something else entirely.
Okay, so we are at time, 11:45. So let's thank all of our panelists.